section 7.5 still. All right, so I might ask you two different questions. I might give you sine of x equals 1/2, and I ask you for all solutions. So you would tell me x is sine of what gives you 1/2? 30, except I'm looking for answers in radians. So you would tell me pi over 6. So that's the answer in the first quadrant, but then what do you do for there is really an infinite number of solutions? Plus 2 pi k.
Well,
Plus or minus 2 pi k, all right. And then you need the answer in quadrant number 2, pi minus pi over 6, which turns out to be 5 pi over 6 plus or minus 2 pi k. So if I asked you to give me all solutions, that's what you would give me. If I asked you only give me the solutions between 0 and 2 pi, Mike, you have a different question?
Yeah, so to find the angle in quadrant 2, you do 180 minus the reference angle?
Correct.
Okay.
So to get the 5 pi over 6, you do 180, or pi if you're working in radians, pi minus your reference angle. That's where I got the 5 pi over 6 from. So if I asked you for all solutions, you would write it this way. If I asked you for only the solutions in between 0 and 2 pi, you would just give me x equals pi over 6, x equals 5 pi over 6. Now, what if I change that slightly? What if I said sine of 4x equals 1/2? What does that 4 do? Besides make the problem harder.
Wait. Divide it over first? Or?
I can't divide it over first because it's trapped inside that sign there. That's not a multiplication, that's a function.
You do 4x equals 5 over 6 plus minus 2 pi k, and then you divide the 4 over?
Correct. So let me ask you a question. Between 0 and 2 pi, when we just had the x, we had 2 answers. How many answers am I going to have when I put that 4 in front of it? More answers or less answers? Let's start with that.
More.
More? Why more?
Because you're expanding your... you mean the purities now, do you?
All right, so there's sine x equals 1/2. Between 0 and 2 pi, it has 2 answers. What's going to happen to that sine graph when I put a 4 right there? How's it going to change the graph? No, the amplitude, if I put a 4 out here, it would change the amplitude.
Frequency is going to increase, isn't it?
The frequency is going to increase, or another way to say that is the period is going to decrease. By how much?
4.
A factor of 4.
Whoa.
Too many x's. So, here's 2 pi. So between 0 and 2 pi, there are now 1, 2, 3, 4, 5, 6, 7, 8 answers. So what does this 4 do? This 4 compresses the graph 4 times. In other words, between 0 and 2 pi, we have 4 complete cycles. So we're going to get 2 answers every time we have 1 complete cycle. So we should now have 8 answers over here. That's a lot of them. All right, so how do we find those 8 answers? We do exactly what Felicia said. Felicia said we're going to take 4x and we're going to make it equal to pi over 6 plus or minus 2 pi k. So just like we did up here, except instead of just having an x, now we have a 4x. And at the same time, we're also going to have 4x equals 5 pi over 6 plus or minus 2 pi k. We're going to take both of those equations and we're going to get the x all by itself. How do you take both of those equations and get the x all by itself? Divide by 4. So this first one becomes x equals What's pi over 6 divided by 4? Pi over 24. Plus or minus 1/2 pi k. 2 divided by 4 is a half.
You said pi over 24?
Pi over 24, yes. Because when I divide by 4, that's the same as multiplying by a 1/4. So 6 times 4 gave me that 24. This one, same idea. I divide by the 4. I'm going to have 5 pi over 24 plus or minus 1/2 pi k. So there's all the answers. All the answers in the world going forever and ever and ever. Now, how do I find just the answers between 0 and 2 pi? All I do is I start plugging numbers in for k. So I'm going to take this first equation. X equals pi over 24 plus 1/2 pi k. And I'm going to plug in k equals 0. If I plug in k equals 0, what do I get? Pi over 24. Then I'm going to plug in k equals 1. That's going to be pi over 24 plus a half pi. What's pi over 24 plus a half pi? Well, I'd have to get common denominators, right? What's the common denominator for a 24 and a 2?
Two. Wait.
It would be 24. The common denominator is 24. So 1/2 would be 12 over 24. So I have 12 over 24 plus 1 over 24. That looks like 13 pi over 24. I plug in the next one. K equals 2. If k is 2, this is just a pi. So what's pi over 24 plus pi? (25 pi over 24), correct. How do you use your calculator to do these? Well, how do I take pi over 24 and add pi? No, I don't change anything to degrees. I never change to degrees. Never, ever, ever, ever. If I'm going to take pi over 24 plus pi, do you agree with me that the answer is going to have a pi in it? Yes. So ignore the pi. Do 1 over 24 plus 1. So I can do my calculator for that, right? 1 over 24 plus 1. And then I can ask my calculator to give me the fraction. 25 over 24, and then I throw the pi back in. Okay, so the next one. I plug in k equals 3. That's going to be pi over 24 plus 3/2 pi. So again, I'm going to take my calculator. I'm going to do 1 over 24 plus 3/2. I ignore the pi's for a minute. That's 37 pi over 24. When do I stop? No.
4.
I stop at 4. Why do I stop here at 4? But we're supposed to have 8 answers, so why do I stop at 4? I got to use the other equation. This equation's going to give me 4 answers. This equation's going to give me the other 4. Or think of what would happen if I plugged in k equals 4. If I plugged in k equals 4, I would get 2 pi here. So pi over 4 plus 2 pi, that would be bigger than my original. I told you to stop at 2 pi. But the other way to think of it is, this equation is going to give you 4 answers, so you get 4 answers. This equation is going to give you 4 answers.
Could you also just figure out that it's going up by 12 each time?
Once you see a pattern, it went up by 12, up by 12, up by 12. Once you see the pattern, it gets very quick. Yes. So, using the same trick, if one of the answers is 5 pi over 24, what do you think the next answer is?
What is this for the next one?
This is for the next one. The next one ought to be 17 pi over 24.
So we're assuming that for the other equation it also goes up by 12 each time?
Yes.
Okay.
And why is that going to be true? Because I'm adding a half a pi,
Okay.
so I'm adding 12 over 24 each time.
Okay.
So you simply keep adding 12 to the top. So yeah, typically once you get 1 or 2 of these done, the rest of them you can recognize a pattern and they come very quickly. So the next one would be 29 pi over 24, and the last one would be 41 pi over 24. There's your answers.
So we go at 0, 1, 2.
So if I needed 4 answers, I would plug 0, 1, 2, 3. What if I needed only 2 answers?
0,
Plug in 0 and 1. What if I needed 3 answers?
0, 2.
0, 1, and 2. Depends on how many answers you need. And how are you going to know how many answers you need? Depends on that number right there. Normally you start with 2 answers. If this is a 4 here, then you're going to need 8 answers. If this were a 5 here, then you would need 10 answers. If this were a 2 here, you would only need 4 answers. So this number right here tells you how many answers you're going to need. Double that number, that's how many answers you need.
So are those first 4 answers for the first equation or the second one?
These four answers came from that solution, and these bottom 4 answers come from that solution. So there's our 8 answers.
For the bottom 4 answers, is that k equals 1 again? Or k
Again, if I wanted to do all the arithmetic, I would take this and I would plug in 0. I would plug in 1, I would plug in 2, and I would plug in 3.
5 pi over 24 if k equals 0.
Correct. So I would use the 5 pi over 24, and then I would plug in 0, and that would give me 5 pi over 24. And then I would plug in 1, so I'd have to add 12 over 24, so that would give me the 17 over 24, and so on and so forth. But again, usually once you do one of them, and you get a pattern and you see you're going up by 12 each time, or going up by 6 each time, or whatever you're going up by, you can write them down, and then the next group you can write them down very quickly also. All right, how about this equation? Let's see, maybe sine of 2x times cosine x minus sine x equals 0. And this time, we're just going to find the answers between 0 and 2 pi. And of course, we'll do it in degrees too. Any thoughts? Do what?
Can you get rid of the sine 2x first?
And how would you get rid of the sine 2x first?
Using the double invertibility?
And I think that's a wonderful idea. Because in general, you want all of your angles to be the same. If I don't want to have a 2x here and an x there and an x there. That's a bad thing. We want all the angles, all the x's to be the same. So I think you're exactly right. I think I want to use my double angle identity there. And I'm going to write that as 2 sine x cosine x times cosine x minus sine x equals 0. I think that's a great first step. Write everything in terms of just the letter x. All right. Good ideas for a second step. Okay, so cosine times cosine is cosine squared. All right, so I can write this as 2 sine x cosine squared x minus sine x equals 0. Factor, excellent. What do you mean factor?
Factor out a sine so that way you have sine x on the outside and then cosine squared x minus 1.
Perfect. Notice there's a sign in common in both of these terms. We factor. So we're going to factor out a sine x, and then we have 2 cosine squared x minus 1 equals 0. And how does that help? What's an identity? It is an identity, that's true. Don't really care about that. Back in algebra, you factored a lot of things. What did you do with an equation after you factored it?
0.
You set each piece equal to 0. That's why you want to have a 0 over here when you factor. After you factor, you can set each piece equal to 0. So I can set sine x equal to 0, and then I can set 2 cosine squared x minus 1 equals 0. First equation, sine x equals 0. X is 0 is a correct answer. Is that in degrees or radians? Both. That's a trick question. That's right. Are there any other spots where sine of x equals 0? Remember, sine of x looks like this. So it's 0 right here. It's also 0 right there. 2 pi is this one over here because it does one complete cycle in 2 pi. So where's that one? That's at pi. In degrees, pi is 180 degrees. All right, so there's that part. And then this one is 2 pi, but we don't want 2 pi because we're not going all the way to 2 pi. We're stopping before 2 pi. All right, how do you solve this equation over here? Add the 1. Divide by 2. Square root. Remembering that there are 2 square roots, a positive and a negative. And then I look at my chart that I've memorized over and over and over again. Is square root of a half on my chart? No.
Wait.
Pi over 4. So again, what you have to do here is rationalize. Square root of 1 is just a nice number. That's 1. Square root of a half is on my chart. Square root of a half is usually written as square root of 2 over 2. So again, you've got to recognize some of these alternative forms from your chart. So how many answers are we going to have here? 4. Why 4? I got to find the positives and the negatives, so there's got to be 1 in each quadrant. Okay, x is. Give me the answer in quadrant 1. Pi over 4, which is the same as in degrees? 45. All right. How do I find, which quadrant do you want to go to next? 2. How do you find the answer in quadrant 2?
180 minus.
It's 180 minus 45, or pi minus pi over 4. So pi minus pi over 4 happens to be 3 pi over 4. And 180 minus 45 happens to be 135 degrees. How about the answer in quadrant 3?
Or
180 plus 45, that's correct, or pi plus pi over 4 if I'm working in radians. That's going to be 5 pi over 4. And 180 plus 45 is 225 degrees. All right, one more to go. What do I do for quadrant 4? 360 minus 45, or 2 pi minus pi over 4. And I get 7 pi over 4. Again, you might start to notice a pattern. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It's all the odd numbers. Look at your numbers here, 1, 3, 5, 7. Or in degrees, 315 degrees.
So how can we turn off 4 in all quadrants?
Why did I need all the quadrants? Because when I did this square root, I got plus or minus, which means the plus told me I needed quadrants 1 and 4, the minus told me 2 and 3. So actually there's 1, 2, 3, 4, 5, 6 answers to that equation total. That equation has 6 answers. Other questions?
So you have to do this for 2 cosine squared minus 1. You have to do it in radians and degrees?
Yeah, because the teacher was mean. He said he wanted answers in radians and he wanted them in degrees. And that's the way it's going to be on the test. I'm going to ask for answers in both radians and degrees. All right, my last problem of the day. How about cosine squared x minus 3 cosine x plus 2 equals 0. So I'm not doing FOIL. I'm doing an AC method is a technique for factoring. That's right, you want to factor. All right, so this is really no different from back in algebra. I'm going to have asked you to solve that equation, y squared minus 3y plus 2 equals 0. And what you should do first is you should try to factor. If it didn't factor, what would you do? Quadratic formula, it's a quadratic equation. Does y squared minus 3y plus 2 factor? I hear votes for yes. Yes? Y minus 2 and y minus 1. So we would get 2 answers. We would get y equals 2, y equals 1. Same thing happens over here, except I don't have the letter y, rather I've got the symbol cosine x. Does cosine squared x minus 3 cosine x plus 2 factor? Yes, it factors as cosine x minus 2 times cosine x minus 1 equals 0. So I get 2 equations, cosine x minus 2 equals 0, or cosine x minus 1 equals 0. This one says cosine x equals 2. That's not true? Why not? It's out of the range. The biggest possible value for cosine is 1. So this equation has no solutions from that side. All right, this one over here says cosine x equals 1. That one does have an answer. X is 0? No?
Zero. Zero.
0?
Zero.
Yes?
Yes. 0 is 1.
Cosine of 0 gives you 1?
Wait, no, cosine of 1 gives you 0.
Cosine of 1 gives you 0?
Cosine of 0.
Cosine of 0 gives you 1? So x is 0. Cosine of 0 gives you 1. That's what it says on our chart that we memorized. Is that the only answer?
No.
No?
One more.
One more?
It's quadrant 4.
Quadrant 4?
Yep.
You think it's the only answer?
Yeah, because if you add 180, then it would be so isn't that your only answer?
It is my only answer.
Wait, why is that?
Why is that? X equals 0 is not in a quadrant. Where is it?
On the x-axis.
It's right on the x-axis. And again, think of your cosine graph. Your cosine graph looks like this. So it hits 1 here. When does it hit 1 again? The only place it hits 1 again is at the end of one complete cycle, which would be 2 pi,
It's the same thing.
which would really be the same angle. It's coterminal. So that equation only has one answer. So that can happen. Look out for those little sneaky ones where there's only one answer. Questions on that?